All right, here is the question that I wanted to go over. In this case, you can see that it's a little different because it doesn't look like a quadratic, and it has two different types of functions, right? Sine and cosine. So the first step, as you can see here on that next line, this one right here, is to convert the double angle into a sine expression. And with that, we just have sine that we're dealing with, which will make things a little bit easier. So once you do that, you'll have to do some foiling and simplifying, right? Or a distributive property, not foiling. Distributive property and grouping like terms. So once you do the distributive property, you can move the 2 over to the left side as well. And then you can kind of order it more so that it looks like a quadratic. So that's where we're here at this step, just before we can start factoring. Now, what I did here also is I kind of switched sides, but you don't have to do that. You can multiply everything with -1. I just wanted a positive coefficient in front of sine squared x. It doesn't really matter ultimately. And I changed the sine into another variable just to kind of make it look more like a quadratic. You don't have to do that, but it might help you recognize the a, b, and c values that you need to use for a quadratic formula. The reason why I'm going directly into quadratic formula is because this one is not factorable with our sum and product. So I go into quadratic formula, and once I apply that, I end up with 2 answers at the bottom here. And like I said, you don't have to use a's. You can still use sine x. And once you apply the quadratic formula and you get the answers to the quadratic formula, essentially it means that you have 2 possible answers. So this is our essentially starting point for our last part of solving the question. Now in this case, we get a positive 0.73 and negative 0.23. And just like in the past, you have to identify which quadrants these values are in, and then based on that, you're going to generate some ratios, or actually some angles. So in this case, I'm just going to scroll down a little more. If you look at the sine x of 0.73, it's a positive value, so that means that you're looking at something in the, let's do that, in the first and second quadrant, because of the positive ratio, right? So that's one angle, that's another angle, so that's going to produce 2 angles. And if we look at the negative value here, the negative value just means that you're going, so let me get a ruler. There we go. The negative ratio means that you are in the third and fourth quadrant, like that. So that'll also generate 2 more angles, like that. We need the related acute angles, so I did that. I did that here, and you'll definitely have to use your calculator in this question a lot. And once I got the related acute angle, and for the other one, there is the related acute angle, and then you just have to do the proper subtractions for the appropriate quadrant. So for this first one, I'm going to subtract the related acute angle from 3.14, so that's this part here, and I will get another angle. And for the second option, I will add the related acute angle to the pi value, 3.14, because we're looking at quadrant 3, and then I will subtract that related acute angle from 2 pi, or 6.28, to get that last option. So in this case, I'll summarize it. We have x1 0.82, x2 is 2.32, x3 is 3.37, and then x4 is 6.05. There we go. So that is the all the possible answers that we generated. Now this question, like I said, it's unique that it doesn't look like a quadratic at the beginning, but after you do some substituting, you do get a quadratic. It is also possible in some questions that you do end up with two different trig functions in the final factored form. So what I mean by that is it might be something like this, maybe like sine x, and actually let me complicate it a little more. It might be like sine x minus 1 and 2 cosine x plus 1, something like that. So you might end up with a factored form that looks like this, which means you would still solve them separately. So you have sine x is equal to 1, and then cosine x is equal to -1/2, and then you would proceed from there. So that is possible that you have two different trig functions that you're dealing with, but you can still solve it and produce somewhere from, one or maybe no answers to a possible 4 answers. And again, that depends on our interval that we're looking at here. We can have a lot of variations of answers here. All right, so that's that. That's the last question. Quiz. So here is the quiz. I took a picture of some of your quizzes solutions, so you can look over it. First and second one, multiple choice. You can see how you just have to apply the appropriate formula and then essentially simplify things or look for the exact value for the trig ratio. So you can check this, pause the video, you can look over it. This next one, you had to split up 11 pi over 12 into two angles and use the compound angle formula. There was a few variations. This person did 8 pi over 12 plus 3 pi over 12. There was people that did 9 pi over 12 plus 2 pi over 12. That was an option. I don't think I saw any subtraction, so that's okay. It doesn't really matter. Ultimately, you will get the same answer. So once you split them up into two angles that add up to 11 pi over 12, you can reduce them just like this person did, and then apply the compound angle formula. Now, mistakes that happen here is in the next step. Most mistakes that happened were here, where people just didn't get the proper value, the exact value that they were supposed to get, or they forgot signs like this, and then that kind of messed up things a little bit. But overall, it was well done. Like I said, usually your answer is going to look something like this, where you have root 6 root 2 over 4 in some form. So it might be positive, negative, but it should have that form for sine and cosine. Tangent is a little different, but this was sine and cosine, so you can almost expect a certain look to the answer. All right, so that was that one, and then there's the last one. Let me just zoom this out. I guess that should be good enough. So you're given a value for sine theta, which tells you also that you are in the second quadrant, so you're not looking at any other options. So once you set up the triangle right here, you're able to find all three sides of the triangle. In this case, if you look at the Pythagorean theorem, you get that that side, the x value essentially, is 5. And when you're defining the tangent, because you are looking at the tangent of a double angle, and when you look at the formula, expanded formula for the tangent of a double angle, you need tangent theta, right? So if you're doing that, tangent of theta is opposite over adjacent, right? It's 12 over 5, but because this is a second quadrant, it makes that ratio negative. So some people miss this. Some people did some complicated things on finding theta. But once you get that theta ratio, you can expand the double angle tangent like this person did here and substitute. So once you substitute the tangent theta, you have a lot of simplifying to do. Essentially, this is, let me zoom out. Yeah, there you go. So now you can see the whole thing. This is the process. Now, this person showed every step possible, which is great. Ultimately, it reduces down to this 120 over 119. And that would be the exact value. There was a few people that did one, I think it turns out to be 1.008. They just punched in a calculator. That would be great, but honestly, on the test, you'll have the exact values. So you'll have to do the exact values. So even though you might have a calculator, you'll have to have it in some kind of fraction. So this is good practice. That's it. So I'm looking at the video time. It's 10 minutes. I'm not going to keep it any longer. Look at the video, pause it if you have to, and look over the steps, and we'll talk about this tomorrow more. Bye.